Welcome to Polynomial Notes, Part 2. We're looking at the order of coefficients in a term. Okay, numerical coefficients come first. So the number of parts come first, so like 3. And then the literal coefficients come next, so 3x. And if you have more than one, then they come in alphabetical order. So the x would come before the y, before the z. Okay. Variables. A variable can have different values. So the variable can vary. That's why it's called a variable. So x is equal to 3. In this case, x is 3. How about 2x equals 16? Well, 2 times what is 16? 2 times 8. So in this case, x is 8. And 4x equals 16. Here, x would have to be 4 times what is 16? 4 times 4 is 16. So here, x is 4. Okay, in the above example, the value of x varies. That is why we call it a variable. A variable takes the place of a number. Okay, not all variables are x. So when we mean a variable takes the place of a number, it's like a variable is like a big cardboard box. It's got a number in it. We just can't see what the number is. All right, so the variable, it's like a holding place for a number. It's like a, I always think of it as a big cardboard box or a paper bag with a number inside it. We can't see what that number is. Okay. So 2x is like 2 times something. It's just the variable represents the something. Okay. Not all variables are x. We can use any letter as a variable. Sometimes we even use Greek letters in higher math, like alpha and beta and gamma and theta for angles and such. Okay. Like terms. Let me move that a bit so you can see that better. Like terms. Like terms have exactly the same literal coefficients with the same exponents, so it has the same variables, okay, and the variables also have the same exponents. All right, for example, 8x plus 2x minus 10x, these are all like terms, all right, they're the same variable. Or 3x squared, take away x squared, plus 7x squared, plus 9x squared, these are all like terms. Okay, 11xyz, take away 2xyz plus 5xyz, these are all like terms, once again. Okay, r minus 6r plus 13r minus 5r, these are all like terms. Okay, these polynomials are made up of like terms. In each polynomial is not. I'm not saying that these like the x squareds are like terms with x's. They're not. Okay, but the x's are like terms with x's. The x squareds are like terms with x squareds. The xyz's are like terms with xyz's, and so on. Okay, 3x minus 5y. All right, x cubed plus 2x squared minus 4x. These are not like terms, by the way. 3a plus 2b minus 5c plus 8d, all not like terms. No like terms in there. Okay, these polynomials are not made up of like terms. Like terms can be added. Very important. So x plus x. Okay, you have an x, someone else gives you another x. Well, what do you got? 2 x's. 4y's plus 3y's. You have 4 y's, someone gives you 3 other y's. What do you have? 7 y's. Okay. You can always, whenever I get confused with this, I always just think of y's as ducks, like 4 ducks plus 3 ducks. Well, you got 7 ducks. All right, that's what you would do with ducks. You do the same thing with y's. 9x squared plus 11x squared, that's got to be 20x squared. And then you can also subtract them, because remember, subtraction is just addition with negatives. So 5x take away 5x is 0. Not 0x's, because 0x's is 0, right? Like if I have 0 rhinoceroses, I also have 0 Tyrannosaurus rexes. It doesn't, 0 is 0. 3y take away 5y. 3 take away 5 is minus 2, and we're talking about y's, so minus 2y's. 4x squared take away 3x squared. It's just 1x squared, but I'm just going to write x squared. I don't need to write the 1, because that means I have 1. Okay? Or both. You could add and subtract at the same time. So 3x minus 4x plus 2x, that's going to give us 1x. Minus 7xz plus 8xz, which is 1. Take away 10xz. 1 take away 10 is minus 9. So minus 9xz. Here we have 2x squared plus 3x squared. Take away 5x squared, which gives us 0x squared, which is just 0. Okay? And I'm going to stop part 2 there, and we're going to continue with part 3. Have a good day.